to review just the second half of chapter 12 that we're going to do. We are only going to do lessons 12.1 to 12.4 for this chapter. We do not go past 12.4. So this used to be a quiz. We were going to make you do a quiz, but we thought we would just do it as a review. You're very, very welcome. You may Venmo me some cash. I need it, so there you go. Actually, I'm fine. Don't worry about me. Okay, so here we go. It says, multiply matrices. Okay, it actually tells you what to do on this problem. These two matrices to show that they are multiplicative inverses. Now, even if you don't know what that means, which you might not, it tells you the matrices. So let's do that. What happened? I've on a quiz a few times over the last few years, probably 20 years, and people get it wrong all the time because they don't even read this part. Multiply the matrices. So here we go. We're going to multiply and down. First of all, kind of getting a little ahead of myself. This is a 2 by 2, and this is a 2 by 2, and these are equal. The result will be a 2 by 2. So here we go. Now, when you are asked to multiply matrices, especially by hand, please show the middle step. It's the work. All right, here we go. We're going to go across and all right, so let's do it. Across and down. So I've got -2 times -7 is -14, and 3 times 5 is 15. So that's going to go in row 1, column 1. All right, now this one I'm going to do row 1, column 2, which is going to go in row 1, column 2. All right, it's getting messy, sorry. So -2 times -3 is 6, plus 3 times -2 is -6. All right. Now we're going to, once we finish that row with all the columns, the next row. So we're going to go across and down. So -5 times 7 is -35, plus 7 times 5 is +35. Okay, and finally one more. We're going to go across and down here. So -5 times -3 is +15, and 7 times -2 is -14. Now, let's see what we get. We get -14 plus 15 is 1. 6 plus -6 is 0. -35 and 35 is 0. 15 plus -14 is 1. That right there is the identity matrix for a 2 by 2. So that's how you can tell two matrices are multiplicative inverses if you multiply them and they turn out to be 1, 0, 0, 1 for a 2 by 2. All right, now evaluate the determinant by hand. Whenever you see by hand, which is going to be on the test, and there's going to be a written section, you need to show work. All right, so here we go. Evaluate the determinant. I'm going to call it A. So the determinant of A equals 5 times 6 is 30, minus 3 times -4 is -12. So we get my old basketball number, which didn't get used, I sat on the bench, and we get 42. All right, the determinant by hand over here, you need to rewrite the first column and the second column only, and then here, this is what we're going to do. We're going to go diagonal. So we're going to do that diagonal, and that one. And we're going to multiply those guys together. So I have 4 times 5 times 1 plus 0, oh, you gotta love having a 0 there, times 1 times -1 plus -2 times 2 times 6. And then let's find out what that is. I'm going to use my calculator because I'm terrible at simple arithmetic. All right, 4 times 5 times 1 plus, the middle one's 0, don't need to worry about that, -2 times 2 times 6, and I get -4. Okay, so that is -4. Now I need to go the other direction. We're going to go that guy or girl, you know, whatever. Or maybe they haven't decided, I don't know. All right, so here we have -1 times 5 times -2 plus the middle one, 6 times 1 times 4 plus 1 times 2 times 0. There's my friend 0 again. All right, so here we get, this is 10 plus 24 is 34, so I get negative 4 minus 34, which will give me negative 38. All right, so just a reminder, make sure that you show all that work, because you won't get any credit if you just do it on your calculator. All right, so the next one, number 3, this one also says by hand. So now we're finding the inverse by hand. And do you remember how to find the inverse? Is 1 over the determinant A, and you take these guys and switch them, and then you make those the opposite. So first of all, let's determine if it has an inverse, because sometimes an inverse does not exist. This matrix, well, it's 9 times 2 is 18 minus negative 8 times 2 times negative 8 times negative 2 is negative 16, or positive 16. Wow. So I get 2. So 1 over 2, take the 9 and 2, pick them up, and 8 is negative, it becomes positive, and 2 also. And so what I want to do is I want to take that 1/2 and multiply it in. So I get 1, 4, 1, and then you can write 9/2 or 4.5, whatever you prefer. So that's the inverse. Okay, for this one, the determinant of B is 6 times negative 5 is negative 30 minus negative 30. All right, so I get a determinant of 0. If I went ahead and tried to do that and find the inverse, it wouldn't let me. And so I want to say the inverse of that one does not exist. Woo. Okay, so this is a problem. Man, I remember people missing this one a lot, so don't be that people. Here we go. For matrix X. We're first going to start by subtracting this on the other side. So minus 1, 2, negative 1, negative 4. So start by doing that. Be careful on your subtraction, okay? That's going to get rid of that. So I'm going to be with times matrix X equals. Now, if you need to use a calculator, shh. So I can, what I can do is matrix A is B. If I B can multiply the matrix there. So I need this. First of all, determinant. It's 8 minus, which is 5. So 1/5. Oopsie. That. Here we go. So 1/5. We're going to switch the 2 and the 4. And the 3 becomes positive, and so does the 1. And I'm going to multiply that on the left side of negative 7, 8, 6, negative 4. Now, for me, I'm not a big fraction fan. Don't tell anyone I told you that. I just don't like them very much. I mean, they're fine. Whatever. I shouldn't discriminate. Wait a minute. Did I do this right? Yeah, we're okay, I think. You guys got to check my work. All right, so I'm going to leave that 1/5 on the outside. And I'm going to go across and down. So here we go. I get 4 times negative 7 is negative 28. Show this step. Plus 18. Okay. And then I'm going to go across and down this one. 4 times 8 is 32. Minus 12. The next one. 1 times negative 7 is negative 7. 2 times 6 is 12. And then finally, 1 times 8 is 8. 2 times negative 4 is negative 8. All right, so we get, I'm going to go up here. We get 1/5 times, that gives me negative 10. That gives me 20. This one is 5. Ooh, it's looking pretty good, and 0. So finally, take that 1/5 and multiply it in, and this is equal to negative 2 There you go. And that's the answer off the page out in the space. I don't know what that is. All right. So how you holding up? You okay? Good. It's good to hear. You're doing great. All right. Now we finally get to use our calculator. Finally. Okay. 2x2s are always by hand. And 3x3s, we may use our calculator. So, except on that one where you had to find the determinant of a 3x3 one time. All right, so find A inverse of A with your calculator in fraction form. Ooh, fraction form, and it's in bold. Okay, so first of all, we're going to start by going to our calculator, and we're going to enter in that matrix. Okay, so Miss Chong taught me some little trick here. I can insert a video of my calculator, and I can show you how to do this. All right, so let's record this. Okay, so I'm going to go into my calculator, and I'm going to choose matrix, okay? And I'm going to choose matrix A. Matrix A. I do not want a 4x2. I want a 3x3. And we're going to put what that 3x3 was into our matrix. So we have 2, 0, 1, 1, 3, -1, 0, -2, -1. All right, be careful that everything looks right. Match it up. All the negatives are there. Okay, so what I want to do is I want to find the inverse of this. So I need to quit second mode, quit out of there, go back to matrix. If I'm going too fast, pause the video. You go back to matrix, and we're going to choose matrix A, and we're going to choose this button right here, X inverse, and the inverse is, okay. Now, that turned out to be pretty ugly, and we want to get this into a fraction. So what you're going to do is you're going to go to Math, and frac is the first one. We're going to take our answer and put it into a fraction. Beautiful. There it is. All right. So, that'd be cool if I just went, there's my answer. Yeah. All right, so A inverse. Cool. I don't know what your idea of cool is. Mine must be different. I just did that. Okay. So A inverse in fraction form is equal to 5/12, 1/6, 1/4, -1/12, 1/6, -1/4. Wouldn't you rather be at the beach right now? Same. -1/3. Summer's coming. Summer's coming. All right. A -1/2. Okay. Fantastic. Let's move. Can I move this? No? No? It's going to stay there. It's just going to stay. So now I'm playing it. Okay. Well, okay. It's going to stay there, you guys. Sorry. Oh, I know. Aha! You guys, I figured it out. I'm so smart. All right, this is a little embarrassing. It's okay. All right, here we go. Now we're going to use the system to answer the following questions. What's going on? Write the system as a matrix equation first. All right, so our coefficients, 7, 1, -2, 2, 3, -4, 1, -5, 6. And then we have our variables and our constant. I don't like that there. Is that bothering anyone else? Oh, it's going to erase everything but that. Oh well, it's just going to have to bother you. Okay. And then -14, 35, -74. All right, there we go. So this is what you're going to do. You're going to plug this in for matrix A, that in for matrix B. To find out what X, Y, and Z are, you're going to do A inverse, don't forget the inverse, times B. So I want you to try that on your calculator right now. I'm going to do it too. Okay, do you want me to record what I'm doing? Why not? Here we go. All right, I messed up on something, but here we go. I think I figured it out. So add a video, and then don't forget to hit record. So go to Matrix, and edit matrix A. And I went ahead and did this. So you put the coefficients in, 7, 1, negative 2, 2, 3, negative 4, 1, negative 5, 6. Okay, now if you need to pause the video, pause it. I'm just going to keep going. So you quit out of there. You go back to matrix, over to edit, but now we want to edit matrix B. And B is a 3 by 1. And the numbers are negative 14, 35, negative 74. And quit. All right, here we go. So now we're going to go back to matrix. We're going to choose matrix A, but we want the inverse of A, and that's found right underneath math, x to the negative 1, times, go back to matrix and choose matrix B, and there's the answer. Okay. Now, if that turned out ugly, then you might have put a number in wrong. Okay. But you can always fix that by looking back at your matrices and see what's happening. So we end up getting negative 5, 3, 9. You really should, since this is a system, it started as a system, you shouldn't have a matrix as your answer. For a system, you should have a point. And so that would be the three-dimensional point, negative 5, 3, whoopsie, negative 9. All right, and now some tricky true or falses. Let's move this guy over here. Tricky true or false. These are tricky. Here we go. All square matrices have an inverse. False. We saw one on the other page, part B on the inverse one, and it was the inverse did not exist. So not all square matrices have an inverse. This is called the coefficient matrix. Ha! No, that's the variable matrix. False again. A square matrix has the same number of rows as columns. Oh, that's what a square is. It's the same dimension here as it is here. Finally, the truth. The multiplicative identity for a 3 by 3 is that. You know, I've tricked quite a few people on that. It's not that. The multiplicative identity is 1, 0, 0, 0, 1, 0, 0, 0, 1. Just ones in the diagonal, not ones all over the place. You're false. And if A and B are multiplicative inverses, then AB equals BA. Now, there was a question on your last quiz that said all matrices, you're allowed to just multiply. What is that, the commutative property? Yeah, something like that. And that's not true for all matrices, but for multiplicative inverses, it's the truth. And this is for fun. And this is where most of you will stop the video and go on your merry way. But this is actually a very, very fun problem here. So if you want to do that with me, go ahead. If not, I will see you later. But I'm going to put something like this maybe on a bonus. No, I probably won't. No, I'll see you guys later. But I'll do it because it's fun for me. I might not even do it. I don't know. So here we go. We need to solve the system. So first of all, you want to write this as in matrix form. So W, X, Y, Z. So that would be negative 2, 1, 1, 0. And then here, the coefficients are negative 1, 2, negative 1, 1. And the coefficients here are negative 2, 3, 3, 2. And finally 1, 1, 2, 1. All right. So then X, no. Don't do that. That is not true. It's this one. It's W, X, Y, Z equals negative 2, negative 4, 2, and 6. So what you're going to do, I'm not going to do it because I got to take a walk with my son. Yes, Jack? Yeah, okay. You would put this in for matrix A. It's a 4 by 4. You would put this in for matrix B. It's a 4 by 1. And then you're going to find out what X, Y, and Z are by doing A inverse times B. There you go. And you will get 4 numbers, and this is W, X, Y, and Z. All right, I'm not going to do it. I'm going to leave you hanging. Yep, I got to go. All right, peace out.